you, Megan, and thank you, Josh. It's a great lead-in talk to my talk, which will show you that water from Lake Okeechobee, it can go east, it can go west, and it can go south. And that's really what I'll be talking about, how we've seen the impacts of fresh water coming down through the Everglades at Looe Key, the crown jewel of the Florida Keys reefs. I'll also be talking about Upper Harbor Key, a tidal flat in the backcountry, about 12 miles north of Looe Key. I'll show you some pictures of that in a second. But the objectives of this project, this is a small project, but was to go out and track dissolved nutrients and chlorophyll A in the water at Looe Key and Upper Harbor Key over a year cycle, and to really tie this into the harmful algal blooms that are developing in these communities. And we did that by also measuring the algae, carbon, nitrogen, phosphorus content, and stable nitrogen isotopes, all this being done quarterly. We also looked at the community of the algae and the primary producers, both at Looe Key and Upper Harbor Key quarterly through this study. This shows you the location of the two study sites. Again, Looe Key, about 4 miles offshore of Big Pine. Upper Harbor Key near the Content Keys in the backcountry, and you can see Shark River up there just under the study sites. This is the major source of freshwater discharge from South Florida. These are high nitrogen discharges coming out. It drains not just the Everglades, but the Everglades agricultural area at the very northern part of the Everglades. Like our other studies, it involves a lot of intensive field work. Laura Heron up top left panel, my dive buddy, they're quarterly diving, collecting samples at Looe Key, macroalgae and water. Come back to the lab, we process these, filter the water samples, we clean up and dry the macroalgae and analyze these for nutrients and isotopes. Okay, this is a Google Earth image just to show you a little bit more about the Upper Harbor Key site. The backcountry guides have been complaining about these algal blooms on these tidal flats for many years now. No one has really looked at these. They're kind of difficult areas to get to because they're very shallow. Upper Harbor Key is the mangrove island. You can see our innermost site was at the shore. We had a middle site along the transect, and we had a channel site along Upper Harbor Key Channel that connects with the Gulf of Mexico. This is what the site actually looks like on the ground. This is an ebbing tide. You can see these turtle grass communities, and you can see that kind of yellow stuff. That's macroalgae growing as epiphytes on these turtle grass communities. Through the course of the study, we saw dissolved inorganic nitrogen generally decrease through the study. Soluble reactive phosphorus increased. It's typically what you see when you get a big injection of nitrogen. The plants take up the phosphorus to balance their growth. You can see these red lines are what we have established as thresholds for concentrations that support very rapid growth in bloom development of these benthic algal blooms. Okay, if we look at chlorophyll A in the water, again, Upper Harbor Key, it goes from high values in the beginning of the study in summer 2011 to lower values, which tracks the total nitrogen, total phosphorus ratio. So this tells us a lot about the source of the water. This high NP water is what's coming out of Shark River, out of the Everglades. That water has an NP ratio of about 150 or so, or more. And so whenever we see this, and we can see there was a lot of green water, a lot of chlorophyll coming with these discharges early in the study. We collected a lot of different types of macroalgae for analysis during the study, and they told us quite a bit about nutrients across these tidal flats. Looking at the stable nitrogen isotope, at the shore site, these brown bars are right around +3 parts per mil. That's the effect of the bird guano coming off that. These are bird islands. And you can see how those values drop off as you come across the flat to lower values that are actually characteristic of agricultural nitrogen from Everglades peat and fertilizers. Carbon to phosphorus ratio down here tells us a very similar story. We have very low values at the shore site compared to the middle transect and channel site, again showing the phosphorus enrichment around the island from the birds. Now if we look at the communities over the course of the study, this goes back to a point Dennis made. This plant Haliduli, which is more of a stress-tolerant seagrass, we see it growing in these higher nutrient halos. Throughout this study, it dominated that inshore shore site compared to the middle site and the outer site that were dominated by turtle grass and to a lesser extent Syringodium. And what was really most interesting is to see the onset of this bloom in the winter of the study right here and extending up into the spring. This was a bloom of an epiphyte of a macroalga that you can see accounted for upwards of 80% or more of the bottom, and this is what it was. And this is what the backcountry guides have been seeing fouling these tidal flat communities. This is Spiridia filamentosa. Literally covers just hundreds and hundreds of acres of these flats these days. Okay, moving offshore to Looe Key. These are 3 of our long-term monitoring sites that we began looking at way back in 1984 with Mark and Diane Littler. Looe Key, the mid-fore reef in the middle of the spur and groove zone, the west fore reef, and the rubble zone in the back. So quarterly, just like Upper Harbor Key, we went out and collected our samples. Again, you see the 1 micromolar threshold. So there's a lot of nitrogen in the water out there, especially around the mid-fore reef area. So you're in the middle of the reef. There's a concentrating effect there of the reef. As you go toward the side of the reef or the back, it drops off a little bit. Soluble reactive phosphorus. Again, you see the threshold. We're pretty much right there. A lot of phosphorus in the water as well. We do see kind of a shift over time through the study of increasing phosphorus. Those green bars kind of increasing in all cases. Chlorophyll A kind of tracked the phosphorus. You can see through the study, just like phosphorus, we saw kind of increasing chlorophyll at Looe Key, which is opposite what we saw at Upper Harbor Key. But I wanted to also point out this 0.1 micromolar threshold for chlorophyll A is what we saw historically at Looe Key. And this kind of goes back to the point Dennis made earlier that we're really working in impacted systems. So this is very much a eutrophic condition, having this much chlorophyll A at Looe Key. These are some of the algae we collected for analysis. I'm not going to talk about that today, given the time. So what I want to share is the long-term data from Looe Key. This is dissolved in organic nitrogen in the water column of Looe Key, going from 1984 to 2012. You can just see how relatively clean that reef was back in the 80s, when we really still had haystacks of elkhorn coral, high coral cover, for some of you that knew that. Look at the flow rate, that Shark River slough. And so Mark, I wanted you to see this because you keep saying, move that water south. This is what happens down in the Keys when that water goes south. You can see the whole system went south. And the point is, it has not come back. Even though the flows of Shark River have come down, the nitrogen has built up in the system. Okay, and everyone asked me, what happened there to make that happen? Ironically, that is when the Florida Keys National Marine Sanctuary lobbied, actually, to have that water put into the system. Neat thing about long-term data sets, patterns emerge. And we now know whenever they put water in there, we get a rise in the nitrogen to phosphorus ratio because of the high nitrogen in that water. This correlates directly, these 2 big releases, with the 2 major coral bleaching events that we've seen in the Keys. We know this condition stresses corals and it reduces their temperature threshold for bleaching by several degrees. This is some of the bleaching, the 2 major events, 87 and then again in 97. Chlorophyll A over time, just showing you again how clean that reef was back in the 80s. Again, it has not return to its original condition. So this is my summary. I just want to maybe make that final point on the bottom that this is a really great example of a shifting baseline, not one necessarily caused by overfishing, but one caused by water quality shifts over time. And I just want to acknowledge all the help, Laura Herron, David Debertoli, many other people, and especially the foundation and the Save Our Seas Plate funds. Thanks.
Brian, thank you very much.